Nigel here again, Nigel's Modelling Bench. Thanks for tuning in. If this is your first visit to the channel, please don't forget to give me a like and a subscribe. Go back and look at my other stuff. There's lots and lots of reviews, there's builds, there's how-tos and tools and all sorts of stuff if you go back through my channel. Not very old, it's only been going just over 6-7 months now really. So yeah, and this is the 1/24 scale Airfix Hellcat, the F6F-5. This is in the FAA markings, this one. I'm also building one in the US Navy markings. If you haven't seen that, go take a look. So I guess this really should be called Hellcat Mark II, because that's how the British term them, Mark I and Mark II. This one being a Mark II. So what we're looking at now, we're sort of jumping ahead a bit in the instructions, and as you probably have already seen in the US Navy version, I have actually jumped ahead and got cracking on with the engine. Main reason was I'm in the middle of doing the cockpit, loads of photo etch from Airscale, beautiful little cockpit set, lots and lots of bits and pieces to be added myself with lead and God knows what. Sometimes you get buried under, you get your mojo gets destroyed because you're doing all this fine work, and sometimes if you don't feel like doing that, what you need to do is stop. Okay, that's my advice to any modeler out there. If you're building a kit that's got loads of photo etch or something and it's just not going well, and the parts keep pinging out the tweezers and your super glue isn't working, you can't get your soldering right, stop, put it down, pick up something else, because all you're going to do is burn your mojo out. Okay, so that's what I did with this one on Monday evening. I think it's Wednesday now, Wednesday the 3rd of July. And yeah, Monday evening I've been doing some work on the Bronco, and I've been doing some work on the US Navy Hellcat with the cockpit and everything, and I thought, nah, I don't want to do this, I want to stick some plastic together. So I thought I'd make a start on the engine, and I glued together the crankcases and everything, and then I cut some parts off the sprue and found that they don't fit at all. And I'm just going to briefly go over now, in case people haven't seen the other one, what I found. Now this is the engine, this is actually for the US Navy kit, but both kits are identical, so it doesn't matter. I could take the sprues out of one and change them over, but this is actually the engine built up, dry fitted together. So we've got a rear gearbox casing, and then on here we've got the front cover, then we've got the, if they'll come off, we've got the front lot of push rods, then we've got the front cylinder bank, then we've got the baffles, then we've got the rear cylinder bank, and we've got the rear push rods, and then we've got the induction ring there, and then our crankcase. So that's how the engine comes apart. So what I'm going to do now, I'm just going to start by gluing all this together. Now if you've seen my my build of the US Navy Hellcat, then you've already seen this, but just in case you haven't, I'm just going to glue this part in here. And by the way, if you want to use the motor, you don't fit this part, the electric motor that is. And then it's just saying on there, do not use this. And then what I'm going to do now, I've cut half of these tabs off, locating tabs, make it go together a bit easier. So there we go. You can see it all locks together and squeezes up together, and everything goes together nice. Now I've got something there which is stopping this one going together, so just gonna get in there. We've basically got sprue nibs over tabs, which is not great. They could have easily put the sprue nibs away from the tabs, but that's where the mold tool designers fail, in my opinion. My favourite one ever is the, I think I've told you this story before, the 1/32 scale Revell ME109G6, and they went to all the trouble of making the fuel rail that runs through the cockpit out of clear plastic, because next to the pilot to his right hand side there is a sight glass, and the sight glass shows the fuel flow. Well, Revell thoughtfully made that part from clear so that you could represent that clear sight glass. Where do they put the sprue connector? Bearing in mind the whole pipe is painted, except for one sort of 2mm length. Yep, they put the sprue connector on the sight glass. I mean, why would you do that? Unbelievable. So put some glue in around that. We want this nice and strong because in a day or so for me, but in a few minutes for you, I'm going to be putting this up on the lathe and machining it. And I've covered it in black magic marker because I want to show you where we need to remove plastic. Now if I put these two next to each other, straight away you're going to see a difference. This one's magic marker is only left in that area there. This has no magic marker on it at all, neither does this. And you also may notice that here there's a step and here there is no step. Reason being, this part is too big. Now, as I mentioned in my US Navy video, what you could do is cut the lugs off of here, cut these lugs off and sand these down to make them smaller, because generally this is the seam here, they're wider that way than they are that way, so they're wider there than they are there, so the diameter is larger there than it is there. So you could sand the halves down to bring them together, because what you're actually producing, exaggerated, is that. Okay, so if you sand them down you can produce a round rather than this. But what I've decided to do, because I've got a lathe, I put them up in the lathe and turn them. So this one has been turned. Now you can see the difference just using this front diameter as an example. Where's that step? That goes in there. So that pushes on there now, and that's a really nice sort of biting fit, yeah, so it all stays together. I've got my digital calipers here, and this dimension now is 17.9mm. If we measure here across the seam, 18.1. Go round here, 18.5. So as you can see, this part is not going to, well, it does, but that's not really suitable. If you can imagine you're holding your engine and trying to push it all together like that, then it's no good at all. This ring here, this is the induction ring. This is supposed to go over there and then onto that diameter at the back. I can't get it on. Okay, it's too tight. Okay, so what I'm actually aiming for here is to have this so that I can assemble it as a painted model, if you like. So I can paint everything and just slot it together like so, he says. I just want to be able to slide everything on like that. Okay, I don't want to have to fight with stuff, because when you have to fight with stuff then you start scratching your paint and you start pushing stuff, you get glue oozing out and stuff. I just want to be able to put that on there, dab a glue, job done, put that on there, dab a glue, job done. And the same here, put this on, just like going to go on like that, and then the gearbox cover is going to go on like so. There we go, and that's how it all goes together. And again, this gearbox cover at the rear, there is no way, I mean, I don't want to force it, but you need all the strength you've got to push that on there. If you look here, I've turned that down to 21.5mm, and this one is 21.8. It does go bigger in places. Here are 21.9, 21.93, so it's nearly 22mm diameter. And the other thing to note is when I show you, there's also a taper on these. Obviously, due to injection moulding, you have to have draft angles when that's in the mould tool. This would be a male surface, you have to have a draft angle on there for it able to pull off. If it was just parallel, it would shrink on and wouldn't come away, so you have to have a draft angle to make things come away. So all of these parts will have a draft angle in them, and you have to take that into account. So what I'm going to do is in this video I'm going to put this on the lathe and I'm going to show you how I machine it. Right, here we go then. So I've got the part in the chuck's done up, and I've had to clock the part true. So because we know the part isn't round, then what we're going to do is we're going to turn the part there until I'm opposite a seam line, the clock's on 0. Then I'll come round to the other side, and the clock's on 0, and then in between there we've got plus 12, 13, and and then we come around here and we've got plus 12, 13. So basically that's taking account of the fact that it's not round, so you basically clock it in 4 places. And before any budding engineers out there tell me that the clock should be square to the surface, yes, it should be if I'm using it as a measurement, but I'm not using it as a measurement, I'm using it as a comparator, so it doesn't matter. Right, you have to cover yourself for every aspect on YouTube. So what I'm going to do now, I've got a drill in here, a little centre drill, number 1. And I'm just going to put a little centre in there so I can give it some support when I'm turning it, because I don't want it to just flick out. So just start up the lathe. Just basically put a little centre in there. So that's drilled basically a conical hole for the centre to pick up on. Then what I can do is put my centre up. All this stuff's a bit rusty these days. This is all very old now and lives in the garage, so it's not in a climate controlled environment. So I'm going to set my tailstock to give it as much room as possible to work. So just wind it back a touch, bring the tailstock up, and now that's in that centre. And I'm not putting enough pressure on it so that it turns the centre, but this is actually a live centre, so if this was metal you'd have it in there tight and it would actually turn it. You can see it's turning it there, but yeah, you don't really want to put too much pressure on stuff like plastic. Okay, so now what I can do is wind this tool away, and the first diameter I'm going to do is this small one on the end. So I may need to mess around with the my compound slide. And I got my compound slide set on about 1 degree to give me 2 degrees. I'm just going to give it a touch more. Just a touch there, that's about 1.5 degrees, so that'll give me 3 degrees inclusive. And now what I'm going to do is set my length. So yeah, now I need to wind my tool post around so that I get some clearance on there. You can see it's just a case of manipulating until we get clearance here and enough room here to move. So enough room here, sorry, to move. So that's fine like that. So what I can do now is come in to roughly the right position, and I'll leave this set where it is, and then what I can do is wind the main saddle over, and then basically use that as a stop, and then just wind this, and that'll end up in the same position every time. So all I'll do is come back in solid, to retouch, and lock the saddle in position, just go to the stop. Now we can clearly see what I'm doing is removing material only on the high spots, which is opposite the groove, as opposite the seam, as I was saying. Okay, so now I've got something that I can measure. Be careful not to get the measurement across the groove, because it'll give you a false reading. Turn your caliper on first, Nigel, it helps. and that's 18.4, and I want 17.95 at the biggest end. Okay, so now I've got a bit more I can measure now. $18.15. $18.06. So one more cut on there by 5. $17.97. I think that'll do us. So what I can do now is just wind this away, wind my tailstock away, and then we'll get the, just clean that out of there. One little knife here, just to clean the debris out of that groove. Take the front cover and it should go straight on. And there we go, nice firm fit on there. Right, so now what I'm going to do is turn this tool around and put it on this side, otherwise if I try and turn, obviously I'll wind the tool post into the chuck, so I'll do that now. Right, so I've turned the tool around now and I've got my depth set here. All I do basically is use the saddle and set the stop on that and lock it, and then I can wind this, the compound slide, and I can come back to the same position every time. So that's what I'm doing there. So I'm looking for 20.8 on this one at the highest end. Remember, I'm putting a taper in, so I'm actually tapering it away this way, so it's forming a cone. So just going to touch down. You should be able to see here again, like I was telling you, if you are sanding this, sand the opposite sides to the actual groove first, to the actual join, the seam first. So that's 21.2. Making sure I keep the digital caliper way over to the one side. So that's 21.1. This should be 21. Give myself a fright then, that's a 21.5. 20.96, there we go. So another couple of thou. That should be it now. Make sure that I'm measuring across the groove. I'm just going to take a touch bore. That should do us. So let's just move the centre out of the way. Scrape off the plastic residue. And see how the part fits. Now I don't think the part's going to go over. No, I need to do this diameter first before I can check that. Now, to turn this diameter, I don't want to put a taper on it, so I've got to use the saddle. So I'm not going to use the compound slide on this. And the centre will get in the way, so I've got to move the centre out of the way. So I'm going to set my we can see here once again that we're taking plastic away from the areas 90 degrees opposed to the seam. So I'm just going to, I know I need to take some more off, so I'll just put a cut on. And that should be about it. Just clean that fuzz off of there. And what are we looking for on this diameter? We're looking for 19.4. .38, that'll do. Remember, this isn't engineering, this is model making. So that fits on there lovely. Just check the cylinders go over, and they do. Nice sliding fit on them. So that's that. Now we can take it out. Turn it around. Nip the chuck up there, and then what I'm going to do is set my depth again. And obviously my depth is going to be that lug there. There we go. see, we've just got contact. Just put a small cut on. Sorry guys, I just hit the camera, didn't I? So there we can measure again. 21.8, and we're looking for 21.5. 21.9. $21.8. $21.7. $21.5, there we go. So let's see how that looks. Again, I'll just scrape the plastic out of that groove. In case I forgot to tell you, that groove needs to be widened. That fits on there, lovely. So there we go, now we've got an engine that fits together rather than one we have to force together with a hydraulic press. So there we go guys, that's the engine all put together, and as you can see we've got an engine now that we can take apart easily and just enjoy really, rather than having to force everything together. So all this can be painted, beautifully painted and detailed, and then probably use alclads and stuff, and then because it's not all tight and everything, we can push it all back together with ease without damaging any of the paintwork or anything, because it all just comes apart beautifully. So there's the that's the crankcase for the FAA. This is the crankcase for the US Navy. I've got a couple of this is slightly smaller and this is slightly smaller on here, so it goes together a little bit easier even than this one. But basically the way I've got this, you don't need to glue any of the cylinders. You can just push them on and then hold it all in place with this front cover, and that'll be job done. So there we are. If you want to know the sizes, here they are. And what I've done, you can see I've got an arrow there, there, and an arrow there. Basically, I've got like a 2.5–3 degree inclusive taper on them to take up the drafts in the molds. So that's 17.95 at the biggest diameter. So if you like, it's kind of, if this is the front of this is the front here, the diameter exaggerated is like that. So I've made it 17.95 at the largest point. Okay, so I understand and fully respect the point that most of you won't have lathes. Some of you will, most of you won't. So you'll have to get around with sanding sticks. But I would seriously suggest, as I mentioned in my other video, cut the lugs off sand the parts, and then you'll get somewhere handy, because as you can see here across the joints we've still got black pen remaining, whereas at the back end we haven't got any at all. But you can see that the line, the depth of cut there is deeper on the sides than it would be up here. So basically, you're making that, you want to make that. So sand plenty of material off the flanges, glue it together, all go together then. But what you don't want to be doing is really forcing everything together once it's all painted. And just as a final note, to those of you that are engineers, budding engineers, whatever, yes, my lathe is old. It is a very old Clark CL500M, and it is now coming up to something like, when did I get it? 1990. So it's coming up to, what is it, 39 years old. So next year it'll be 40 years old. So it spent all its life in various garages, and that's why it looks a bit tatty, that's why it looks a bit worn. It's done a really good job, and I'm really pleased. I've replaced the head bearings once, and that's it really. It's a great little thing, and I know it's not the best lathe in the world, and I know that a million people out there are going to tell me I'm doing this wrong, I'm doing that wrong. Please just don't bother. So anyway, I'll speak to you all soon, and thanks for watching this one. This has been part 5, I believe, a fairly short one, but just wanted to really show you how I machine this, because I know a lot of you guys, even if you don't have lathes, are interested to see how things are machined. So yeah, I'll see you all soon for part 6. Bye for now.